Hi everybody. Now already we have discussed what is diffusional flux. We have discussed what are the variables associated with this diffusion process, molecular diffusion process, and how the flux is related to the driving force, that is the concentration difference. That means we have already discussed Fick's first law. Next task is to apply Fick's first law, that is the equation which correlates diffusional flux with the driving force of diffusion, that is concentration difference across unit length for a particular problem. So let us have a problem where the diffusion process is happening and you are assigned to calculate the diffusional flux. For the present problem, carbon is diffusing through a plate of iron and you are supposed to calculate the flux. Now the position 1 is carbon rich position. This is the facing surface, and if this is point 0, that is the upfront surface or the reference point through which this distance is 5 millimeter thickness. So this is 5 millimeter of the particular iron plate and this distance is 10 millimeter. So if you are assigned to calculate the flux across this length, that means for the 5 millimeter distance, then you need to apply Fick's first law. Now the data available are the concentration at this point is 1.2 kg per meter cube at steady state, and concentration at this point, that is the remote point, is 0.8 kg per meter cube. So if this is so, then you are supposed to calculate the diffusional flux across this 5 millimeter range. What else we require for calculation is the diffusional coefficient or the diffusivity. And for carbon, with respect to iron plate, this is nothing but 3 into 10 to the power minus 11 meter square per second in SI unit. It is evident, quite evident, that the diffusional flux or diffusivity is very low value because this time carbon is diffusing a solid plate. So diffusion coefficient must be very, very low. Therefore, with the data available to us, the diffusion coefficient, diffusivity, and the concentration at position 1 and concentration position 2, we are now assigned to calculate the flux through this distance. So think on this particular assignment, try to recall the Fick's first law and try to apply Fick's first law to solve this problem. This is very easy. Only thing you need to put the numerical values in the respective position in the Fick's law and then simply calculating the flux. This is nothing but a simple simplification process, nothing else. because each and every data are available to us. Concentration difference, that is C1 and C2 is given, and the D value is given, as well as X value, that or dx value, or the distance through which the diffusion is happening, is also given to us. So think on it. We will be solving the problem shortly. Thank you.